Okay, so greatest common factor. So we're going to look at these problems and try to pull out the greatest common factor of those together here. So number one, what's the GCF of 12K minus 18? What goes into 12 also goes into 18? 6. So that would leave us what in parentheses? 2K minus 3. Yeah, don't forget we got to be able to multiply this 6 back out and get the original back out of that. So there's the factoring of that first little binomial there with the 6 as the GCF. All right, number 2, stepping right across, the same idea, it's GCF, but we have X's and Y's, and we got a bunch of them. Because we got an X to the 8th Y, and then we have an X to the 4th Y, and we got 40 and 64. So let's start with the number part, because that's the easier part. 8 goes into 40 5 times, 8 goes into 64 8 times, 5 and 8 don't have anything in common. So that 8 would be the GCF on the number part. How many X's do they have in common? 4 X's in common. Because the first one has 8, the second one has 4, so there's only 4 that they could have in common. So X to the 4th. How many Y's do they have in common? 1. So there's our GCF, 8x to the 4th y. What's left over?
5x4 plus 8.
Well, it's just 8. That's good. 5x to the 4th, 8 times 5 is 40, so that would be that part. 4x's and 4x's added together would be, or multiplied together would be x to the 8th. And then y times that would get the y on the end. 8 times 8 is 64. X to the 4th times that is going to get us x to the 4th, and y gets us that. So pulling out GCF of a larger polynomial out of that. Okay. Let's try number 3. Got a trinomial. It's got 3 terms. We're just going to factor out the GCF on this one. So 14m to the 6th, 35m to the 3rd, and a 7m squared. 7 goes into all of those. How many m's? 2. 7m squared. What's left over? What times 7 gets me 14? 2. M to the 4th. Good. What next?
Minus 5 to m. Not minus 5m.
5m. Technically, it's m to the 1st power. We don't have to write that 1. And then minus. What times 7m squared gets me 7m squared? 1. A 1 at that last piece. Okay. So anytime you pull out a GCF, there should be a representative from each term left over in there. So don't forget that. That's the most common mistake on this stuff is forgetting to put that 1 for that if one of your terms happens to be the whole GCF. Okay. All right, number 4. Got 3 terms and 2 variables in those. So a little tougher here. 3ab squared minus 5a squared b plus 8ab. So 3, 5, and 8, do they have anything in common? 1's the only thing that goes in all 3 of them. So they're called relatively prime out of that. So what is the GCF? Yeah, just AB. 1A, 1B. So the first term, if I take the A and one of the B's off of it, what's left? 3B. The second term, be 5A. Good job. The last term, plus 8. Good job. It's a little, sometimes you got to be really attention to detail on the things that have multiple variables. Really pay close attention to those. Okay. All right. The next set here is trinomials, and it's where a is equal to 1. So we're going to be factoring these where a is equal to 1. A is the number in front of x squared. If you're dealing with a trinomial. When you're factoring, you always look for what first? Hint, hint. We just did You're always going to look for that first, because if you can pull a GCF out of that, it makes everything smaller. And smaller numbers are easier to deal with than larger ones. And you have less options as far as your X goes. Okay. So with trinomials, we're going to factor these, and we're going to use that X that we just practiced to get things going. So like number 5, we're going to make the X over here on the right. 1 times 45 is 45. That goes up top. And then 14 is the number in the middle. That goes in the bottom. Notice that there was not a GCF across all 3 terms, 1, 14, and 45. We knew that there wasn't a GCF there. Okay? So we need things that multiply to be 45 that add to be 14. 9 and 5. And here's a shortcut with factoring trinomials that have an a of 1, or number in front of x squared is a 1. You can take the sides of your x, and because that is not working, there we go. That's a positive 9, so that's going to be x plus 9. That's a positive 5, so that's going to be x plus 5. That is the shortcut to factoring things that have 1 in front of x squared. If there's another number there, we can't do that. But because there's a 1 there, we can take that shortcut. All right? Number 6. Take your x, multiply to be 26, add to be negative 15. Positive 13, positive 2?
Oh, it's negative 15. Negative 13.
And positive 2?
No, negative 15.
Negative 2, yeah, because it's got to multiply to be a positive 26 and add to be a negative 15. So 1 times 26 gets me that positive 26 up top, negative 15 in the bottom. So we've got to have double negatives. And we can take that shortcut. Because it's a negative 13, we're going to do W minus 13 and W minus 2. And you will catch me trying to swap letters to X's a lot. Normally we'll see X's in there, but they can use whatever variable they want to there. Okay? Let's do number 7. Multiply to be what? What goes on top? Just 48? Negative 48. Very important that you get the sign that goes with it. And then on the bottom of the X, positive 2. We need something that multiplies to be negative 48 and has to be positive 2. 8 and a negative 6. 8 times negative 6 is negative 48. 8 plus negative 6 is positive 2. There's nothing in front of the c squared, so that means I can take my shortcut and go c plus 8, c minus 6. If you wrote c minus 6 first and c plus 8 second, it's the same thing. Doesn't matter. That's that commutative property of multiplication. Doesn't matter what order you write it in. It's the same. Okay. Not too difficult. This is pretty easy stuff. Let's do number 8 there, because it's got that 1 in there that makes it. Sometimes we get a little squirrely on those. So what goes on top of my x? Negative 72. What goes on the bottom? Negative 1. Multiply to be a negative 72. Add to be a negative 1. Things that multiply to be 72. 9 and 8 multiply to be 72. We need the negative to be on the larger number. Negative 9, positive 8. N minus 9, n plus 8. That's my factored form. Again, if we can get the factored form, we're going to be able to solve it really easily. Factored form is a key. Let's jump down there to number 11. Skip 9 and 10. We won't do every example all the way through. Let's do number 11 and 12 here. 2k squared minus 16k minus 40. So it's a trinomial, so my brain goes, oh, do the x. But what do I have to do before I can do the x? Which is? 2. 2 goes into all of those. So I'm going to factor out the 2 and change it to k squared minus 8k minus 20. Then I'm going to do the x on the part in parentheses. Okay. So that's going to be negative 20 up top, negative 8 on the bottom. So what multiplies to be negative 20 and adds to be negative 8?
Negative 10 and 2.
Negative 10 and 2. What was the other one? Somebody said? Say the same thing. Negative 10. Negative 10 and 2 is the correct set. Now, what's the factored form of that? You got k minus 10. You got the k plus 2. But that GCF is part of it as well. It has to be in the front there to be the fully factored form. All right, so be careful of that. Don't drop the GCF if you pull one out of the problem. Don't just drop it. Have it there for your factored form. So when you're working these, I'd like to see at least your x that you're doing, especially on the ones that have a 1 in front of the leading term. Then there isn't a whole lot of work to do. Let's try number 12 real quick. Get another one like that. What's the GCF on 12? 5. 5. So z squared minus 5z plus 6. So we're multiplying to be 6, adding to be negative 5. What does that? Negative 3 and negative 2. So that'd be z minus 3 and z minus 2. I put a little slash through my z's so that they don't look like 2's because my 2 looks like a z sometimes. So be careful of that. Don't confuse yourself. All right. Now, that gets us through a being a leading coefficient of 1, factoring trinomials using the x method. Let's look at the ones where you don't have a 1 in front. You have another number. Don't forget, first step is always look for what? GCF. If there is one, pull that out first, and then do any other kind of factor you can. With these, like number 13, you have 2x squared minus 15x plus 18. Is there a GCF on that one? No. The 15 messes it up because it is not divisible by 2. So we're going to do our x method here. What goes on the top of this x?
15.
No. Don't forget, to get the top of the x, it's always whatever's in front of the x squared or squared term times the number on the end. So 2 times 18 would be 36. 36 up top, negative 15 in the bottom. That's the thing that usually will mess us up is we'll do an 18 up top, and you're going to struggle finding the numbers when that happens, okay? So multiply to be a positive 36 and add to be a negative 15. Negative 18 and negative 18 and 2 would get us negative 16, not 15. Negative 12 and negative 3 would get us a positive 36. Negative 12 and negative 3. Now, here's the difference in this and what we did before. There's not a shortcut. You've got to use that GCF type factoring to help us do this. So what we're going to do is we're going to replace that middle term with these two. And we're going to create a polynomial that we can group. So we're going to rewrite it as 2x squared minus 12x minus 3x plus 18. It does not matter what order you put these two numbers in there as, okay? If you wanted to put the negative 3x first and then the minus 12x, it works out the same at the end. I always try to look at it and say, okay, which one has something in common? The 12 has something in common with 2, so I put it first. It's easy to see. It doesn't matter, but that's always what I try to do. Now, the next step on this is you got to group. So we're going to group the first two together with a parenthesis, and then I always underline the second pair. Okay? And I work them kind of as two separate problems. What's the GCF on the parentheses set? 2x. So I'm going to pull a 2x out to the front. And what's that going to leave in those parentheses? X minus 6. Now, what's the GCF of the underlined? Okay, it's 3, but because this is a minus sign in the front of the 3x, we're going to pull a negative 3 out. So if I pull out a negative 3, that's going to change the sign to a positive x. Yes, and the key here is those parentheses have to match. If they don't match, something has went wrong. Okay? So when you pull this GCF out of here, you got to pull out the right one to get those to match. If they don't match, you've got the wrong numbers in your x, or the polynomial is not going to factor. So you got to check all of those things. A lot of checks and balances here. Now, because these two match, that means that parenthesis is really a greatest common factor between these two things. So we get the final factored form will be, whoops, change back to my pencil here. X minus 6, that's the matching parenthesis. And the other factor is the stuff in front. 2x, yeah, 2x minus 3. These are more difficult than the ones with the 1 in front, obviously. There's not a shortcut to it. It takes this extra step. When I learned to factor when I was in high school, we just opened up 2 sets of parentheses and guessed and checked, which works. And if you're really good at multiplication tables, yeah, you can get there pretty fast. But this method is really, more of a process, and it always works type thing. So I think going through this grouping stage is the better way of doing things. So I learned to do that when I was in college, which would have helped me a lot in high school, but it didn't. I didn't know it. All right, so let's try 14. We have 5p squared plus 22p minus 48. Is there a GCF amongst all of those? All right, so what do we do next? Multiply. 5 times negative 48. 5 times 40 is 200. 5 times 8 is 40. So 240. Is that right? Negative 240. And if you'll kind of listen as I'm doing that multiplication stuff in my head, it'll help you learn to be able to do it too. Think about breaking things into sets that you know how to do. 5 times 4 is 20, but 5 times 40, you add an extra 0, so that's where I get the 200. 5 times 8, we know it's 40, so you add those together. And then on the bottom, we want to multiply to be 22. So it gets a little bit more difficult when the numbers are larger. Okay, so we're multiplying to be 240, negative 240, and adding to be 22. So we know that the numbers are pretty far apart. Okay, so think about, when I have a number that ends in 0, I usually will start with things that I know, like this 240, I'll start with things I know to multiply by 24, and then add a 0 to one of them. So my first guess at this would be maybe it's 12 times 20, which would be 240. But if I make the 20 positive and 12 negative, that doesn't add to be 22. So that's not it. So I need to try something else. Okay? So give me a educated guess at this. Something that multiplies to be 240, negative 240, and adds to be 22. So I tried 12 and negative 20, and that did not give me the right addition.
Well, 9 and 13.
9 times 13,
I don't know what that would be.
that's not 240, because 9 times 12 is 108. That didn't go in there. 9 doesn't go into 240 because 2 plus 4 plus 0 is 6. And it's got to be divisible by 9 to be, for 9 to be a factor of that. Okay? So if I know 12 and 20 go into it, I also know that 6 goes into it. How many times does 6 go into 24? 4 times. So 6 would go into 240 40 times. So maybe that's a guess. 6, negative 6, and positive 40. Well, that's a little closer because negative 6 plus 40 is positive 34. That's closer to 22, right? So I need this number to be a little bigger, a larger negative number there. So if we're thinking about things that multiply to be 24, 8 goes into it. How many times? And so if it's into 240, it would be 30, right? Negative 8 plus 30 is 22. That's the right pair. Okay? I'm trying to help you think your way through these things and kind of model how I think through them and how you can get to them. It's not magic that people are able to get these. It's just knowing multiplication tables and knowing that if there's a 0 on the end of it, I can just think about the numbers in front of that 0 and then add a 0 to one of those. Okay? So that can help. So now I have the right numbers on my x, so I need to go and rewrite my problem as 5p squared. And then you need to choose, do you want to put the negative 8 next or the 30? I'm going to put the 30 next. Plus 30p minus 8p minus 48. Okay, so I've taken the two pieces from my x and put them in the middle of my problem. It doesn't matter what order you do it in. I chose to put the 30 with the 5p squared because I know 5 and 30 have the GCF of 5. Okay, and I know 8 and 48 have a GCF of 8. Okay, so I'm going to group then. First group, GCF is 5p, p plus 6. Second group, that's a minus 8p and a minus 48, so they have a negative 8 in common. And that changes the signs to p plus 6. Notice the parentheses match. Whatever sign is right here will be the sign that's right there in front. Always. Always. So if this is a positive here, it'll be a plus sign there. If it's a negative here, it'll be a negative there. Always. Okay? So we have the matching parentheses. So we know that the factored form of this is going to be p plus 6, the matching piece. And then the other one is what?
5p minus 8.
Yeah, the stuff in front, 5p minus 8. And you factored that trinomial. Okay? Not too bad. It's going to get there. We'll get better at it as we go here. We'll get faster at it too. All right, let's go over to the back there. Let's look at a couple of those. 3h squared minus 19h minus 40. 3, 19, and 40. Do they have a GCF? No. 19's prime, so it's 3. So that limits that. So we're going to multiply and build our x. What goes on the x? Negative 120. Not quite as big, but it is still a number that ends in a 0, so that's going to help us. Now on the bottom, we got a negative 19. So we need numbers that multiply to be negative 120 and add to be negative 19.
Negative 17 and negative 2.
Negative 17 times negative 2 would be positive 34. Nowhere close to negative 120.
Sorry.
We want to multiply to be a negative and add to be a negative. So what do we know about our answers? One's positive, one's a negative. Which one is negative? The bigger or smaller one? The bigger one. Whatever the sign, if this is a negative up here, the bigger number will be a negative if the bottom is negative. If the bottom is positive, the bigger number will be positive. So we want to multiply to be negative 120 and add to be negative 19. That means the negative number is pretty big compared to the positive number. Because I'm thinking what multiplies to be 12? 6 and 2. So that could be 6 and negative 20. But 6, if I do a positive 6 and a negative 20 as my sides, that adds to be negative 14. Really close, but not right, not the right ones. Okay? So we need to try something different. 4 and negative 30, which adds to be negative 26. Not quite. Let's try again. 2 and 60 would get worse, right? We know not to try that. 10 and 12, that's only negative 2. That's not enough. What else goes into 120? Maybe it's not a multiple of 12. Three goes into 12. How many times? 4 times. So it'd be 3 and 40. That's getting further apart. Not quite, not the right one. So we need a number. What number is between 6 and 4? Does 5 go into 120? Yeah. How do we know 5 goes into 120 without doing the calculator? Yeah, 5 goes into anything that ends in a 0, right? How many times does 5 go into 120? 2. 5 goes into negative 12 2 times with 2 left over, and 24. What's negative 24 plus 5? Negative 19. Okay. Once we've done that, 3h squared plus 5h minus 24h minus 40. Again, it doesn't matter what order you put the middle pieces in there. You're just replacing that negative 19 with the two sides of your x method. Then we're going to group. What's the GCF of 3h squared and 5h? H. Gives you 3h plus 5. And then we get GCF of negative 24 and negative 40. No, it's going to be a negative because that's a minus sign in the middle there. 8. 3h plus 5. So 3h plus 5, h minus 8. And there's our factored form. This takes practice. I know. How are you good at it? You do a bunch of them. The more numbers you've seen, the better you are at it. How does Mr. Talent know how to fix cars and things back here? He's been doing it for 20-something years. That's how you know that. I mean, that's just the way it goes. I watched a kid was playing baseball this summer, and our little team hadn't played as much baseball as some of the things we were playing. And there was a ball hit, a little pop-up between, it was kind of in the middle of the catcher, the pitcher, and the first baseman. These kids are 7 and 8 years old. It's a pop-up, and none of the three could get to it. But they were telling each other as they ran toward the ball, let it go, it'll bounce foul. They had played enough baseball to know that the ball was going to bounce foul because of the way it was hit. I mean, and that just comes through experience. That's not something you could teach a kid. It's something that you just experience. These things take experience. Some of you have more experience with it from your Algebra 1 class than others do. And I know that. We're going to try to get some experience today and tomorrow for sure with this. Okay, let's try number 16 because it's the first one that has a bigger number in the front than the other one, than the back. So let's try number 16 real quick. We'll see where we're at for today. All right, 12x squared plus 5x minus 2. That's our trinomial. What goes on the top of our x? Negative 24. So a smaller number. We feel a little bit better when we get these 2-digit numbers up there instead of the big old 3-digit numbers or 4-digit numbers. Multiplying to be negative 24 and adding to be 5. Boy, that seemed a lot easier, didn't it? It's that overload principle. In football, you lift more weight than you're ever going to have to push around. Oh, what did I forget to do? Replace the 5 with the 8x minus 3x minus 2. I usually will put the negatives together. If I got one that's got a negative and the end part is negative, I will put the negatives, I'll match them up together just because you're less likely to miss that sign because there's 2 of them there. You're seeing it twice, so you think, that's kind of hard to mess it up. First group, what's the GCF? 4 and an x leaves us 3x plus 2. And what can we pull out of the second group? Except for what number always goes into stuff when nothing else will?
Oh, you can do
A negative 1. That's what we can pull out of that. And that'll turn it into 3x plus 2. And remember, whatever this sign in the middle is, that's going to be the sign in front of those parentheses. Always. Every time. Okay? All right, so we got 3x plus 2, 4x minus 1. We've got the factored form of that. Okay? All right.